Good afternoon, everyone. My name is Nancy Huddleston, and I'm a Communications Director at the National Academies of Sciences, Engineering, and Medicine. Thank you all for joining us for this webinar and what is a very hot afternoon in Washington, D.C., and likely where you are too. We will be presenting the findings of the report that was released earlier today titled Potential Environmental Effects of Nuclear War. You can now download a copy of the report and other supporting materials at nap.edu, which is our National Academies Press. A recording of this webinar will be available on our website in the coming days. For those of you not familiar with the U.S. National Academies of Science, Engineering, and Medicine, we are private, nonprofit institutions that provide independent, objective analysis and advice to help solve complex problems and to inform public policy decisions related to science, engineering, and medicine. For each requested study, panel members are chosen for their expertise and experience and serve pro bono to carry out the study statement of task. The reports that result from the study represent the consensus view of the committee and must undergo external peer review before they're released, as did this report. Just a few reminders. Please note that this webinar is scheduled to last for 1 hour. We'll start off with a presentation summarizing the report from the committee co-chairs, and then we'll open it up to any questions you may have, at which time more committee members will join us, and I will introduce them then. To answer a question, please use the Slido box, which is right below the webcast that you're viewing, and you can submit a question at any time during the presentation. And now I'm very happy to introduce our main presenters for today. First is Dr. Tony Busalaki and Dr. M.D. Chang, who served as co-chairs of the study. Dr. Busalaki is the president of the University Corporation for Atmospheric Research, and he is a member of the National Academy of Engineering. Dr. Chang is a distinguished R&D staff scientist in the Environmental Sciences Division of Oak Ridge National Laboratory. Tony, over to you.
Thanks, Nancy, and good afternoon, everyone. And thank you for the opportunity to brief you on this challenging and important study. We're really grateful to the support and sponsorship of this study by NNSA, the National Nuclear Security Administration, whom we had the opportunity to brief yesterday. And on behalf of the committee, really want to express our appreciation for the opportunity to perform this work and provide this service to the nation. So over the next 20 minutes or so, MD and I are going to provide an overview to you of the study context and the statement of tasks from which everything on the report flows, an overview of some of the key considerations, the report's findings and recommendations at a high level, and then we'll open it up to discussion for your questions and comments. As Nancy mentioned at the outset, the academies provide independent, objective advice to the government, going all the way back to President Lincoln. And one of the unique aspects of the National Academies is its ability to marshal expertise across a broad range of disciplines and sometimes contentious issues. And as I'll say in a few moments, that depth and breadth of the expertise is really brought to the fore in this report. Now, this study has built on previous relevant Academy studies. Just a few in the last several years are illustrated here, those dealing with Earth system science. And that's going to be a theme running throughout this report, is the importance of looking at this topic as a system of systems. Research on atmospheric chemistry, a very pertinent topic. And I stopped from saying a hot topic. Fires in the urban and wildland interface areas, but that aspect of smoke coming from these wildfires is a topic that we built upon. And so why is this topic important? Over the past 35 to 40 years since the nuclear winter concept first emerged, there have been significant military, political, and technological changes on the nuclear landscape, as well as significant advances in our understanding of an ability to model Earth as a system. For example, we've seen nuclear stockpiles have been reduced by about an order of magnitude since the peak of the Cold War. Yields have been reduced. Accuracy, military strategy, and geopolitical actors have evolved. Dynamics of society have changed. We now live in an era of globalization and interconnectivity with complex supply chains and interdependencies that span multiple continents. And so these developments have raised questions about many of the key assumptions underlying earlier projections of the impacts of nuclear war. And that's what set the stage for this study and why we were asked to do this by Congress. Another thing I should mention while we're on this is I'd be remiss if I did not acknowledge what's been happening on the world scene over the past week or so. And first, there is no direct impact with what's happened in the Middle East and this report because the armed conflict we saw in Iran is outside the scope of this report because it involved conventional weapons. There were no deployment of nuclear weapons. As you'll see in a moment, radioactive fallout and dispersion of radioactive materials is beyond the statement of task. But there are some aspects that are relevant with respect to a regional conflict and the interconnectedness of the Earth. I mean, we've already seen potential threats to close the Straits of Hormuz and what that would mean for oil supplies, et cetera. So that's an illustrative of something that's relevant to this report, as well as the deployment of precision-guided munitions. So the statement of task is paraphrased here, and we were charged with performing an independent review of the potential environmental effects and socioeconomic consequences that could unfold on timescales of weeks to decades after nuclear wars, and explore a range of scenarios from small-scale nuclear exchanges to large-scale nuclear exchanges between major powers, and then again consider the non-fallout implications for atmosphere, terrestrial, marine effects and their consequences, changes in weather patterns, impacts to the Earth system, airborne particulate concentration, stratospheric ozone, agriculture, ecosystems. Now, there are two phases to the study. The first phase was classified, and that was to evaluate the modeling and assumptions used to generate the source term to the atmosphere as a result of nuclear detonations, the amount of essentially soot going into the atmosphere, and then looking at the partition between the between troposphere and the stratosphere. And that report had been previously delivered to the sponsors. And we're here today to discuss the unclassified report. And that aspect of the report was asked to deal with and address a representative set of explosive yields, general type, numbers of nuclear weapons, and then review the understanding and tools, essentially models for simulating the characteristics of fires after such explosions and those characteristics of the soot material launched into the atmosphere and the transport of that material, and then the subsequent impacts to the climate and environmental effects on timescales from months to decades. And then look at subsequent changes from the physical system to the ecosystems to socioeconomic impacts, and then identify what are the key uncertainties across this chain of links, the data gaps, and then recommendations to the sponsors and the government. I've done a range of studies in my career in support to the academies. I would say this is one of the most challenging, at the same time, most exciting. And going back to the purpose of the National Academies, the 15 members of the committee listed here really speaks to the depth and breadth of the expertise that the academies can marshal across nuclear policy, military strategy, weapons deployment, dispersion modeling, atmospheric dynamics, stratospheric processes, atmospheric chemistry, hydrology, oceanography, marine and terrestrial ecosystems, biodiversity, agriculture, human health, fire combustion, to name a few. And now let me turn over to my co-chair, MD.
So this is a snapshot of the report. 8 chapters, including the intro, conclusion, and the end executive summaries. Chapter 2, 3, and 4 address the weapon employment scenarios, weapons effects, material transport and transformation in the atmosphere, which lays the foundation for this study. Chapter 5, 6, and 7 discuss the study about the impacts to the physical Earth ecosystem, and the human social economical systems. Next slide, please. So some key considerations for these studies. Scenarios for weapons employment. We are not prescribing actual nuclear conflicts. Provide the basis for modeling of atmospheric source terms across a range of employment scenarios, and the material transport into the atmosphere, especially injection into the stratosphere. And we talk about the uncertainties vary across different sections of the causal pathway, which is going to be in the next slide, particularly in those dominated by human behavior. And the committee recognized the importance of radioactive fallout, as Tony alluded to, but was instructed not to address the effects of fallout on the environment and on human society. Next slide, please. So this is a graphical illustration of the logic for the studies. Okay, each box maps a chapter mentioned previously and divide in with details for the subsystems. So we could analyze each individual parts that are in the box, discover what the data gaps may be, and determine what's the known and unknown associated with our findings. So one thing to keep in mind is at the bottom arrow on the uncertainty propagations. The uncertainty is very likely to grow from the left to the right due to the multiplicative nature of the uncertainty propagation in a complex system like what we are talking about here. Next slide, please. So now I will summarize for chapters 2 to 4. So on employment scenarios and weapon effects, chapter 2. So if we treat this study as a mathematical analysis, then the employment scenarios will be like the boundary conditions, right? The weapons effect will be our initial conditions towards solving the system of partial differential equations. So in the employment scenarios, 2 superpowers fire all the nuke warheads they have for each others and create a detonation that produce huge amount of black soot elevated into the stratosphere, shielding the sunlight, creating nuclear war scenario. That's the scenario that Tony was alluded to, has been studied significantly in the past. 4 decades come by, nuclear stockpile been reduced significantly, military strategy, weapon technology have advanced, and more countries have nuclear weapons today than in the past, and some are even interested in acquiring. So for conducting the study, we were tasked to do a subset of the committees who have the security clearance. We are tasked to develop the 4 scenarios spelled out here in the slide. These 4 scenarios include the war by superpowers, a moderate scale strategic exchange, a small scale nuclear war, and a single detonations as a show of force. So again, these 4 scenarios offer a plausible basis for the downstream studies, but did not prescribe the actual conflict. Next slide. So that leads us to fire dynamics and the emissions of the pollutants and that Tony mentioned earlier. Keep in mind, nuclear detonation has the potential to produce large fire, which could lead to production of tremendous amount of soot particles that transported into the stratosphere by the mechanism called self-lofting. This could lead to the nuclear winter scenario mentioned earlier, but moderate to small scale fires, on the other hand, could also produce air pollutants, PM2.5, PM10, number of toxic gaseous species that can adversely affect human health and ecosystem. So emissions of the air pollutants from nuclear detonation would depend on how the fire starts, right? How they grow, and eventually how they goes out. And also depends on fuel composition and the fuel load, how much fuel are available to burn. So at the moment, there's a lack of fuel data, which is a significant uncertainty in advancing the science of this subsystem we are talking about here. The data are like fuel composition, fuel load, combustibility, the spatial distribution of fuels, and so on. So among the data that really needed are particulate carbons, black carbons, organic carbons, and so on. And size distributions of aerosol particles have been produced, concentrations of gaseous species. So the committee identified insufficient understanding of the fire ignition and spread processes as a roadblock for development of better fire models. Next slide, please. So this chapter, chapter 4, talks about polymerized fate and transport of aerosol and the gas phase chemistries. So this chapter basically lays out the foundations for how particulate and gaseous material are produced by nuclear detonations and how they could be transported, transformed, and distributed in the atmosphere, including troposphere and the higher up the stratosphere. So the factors associated with the plume rise, including the yield, the height of burst, and the environmental conditions that the nuclear detonation occurred, and so unknowns such as the vertical distributions of water vapor could also affect the plume rise. Material produced by nuclear detonation include fragments or small aerosol particles from the makeup of the bomb and the environment which the particles come in contact with. For example, aerosol and cloud interactions, wet depositions, and so on. So the beautiful cartoon that you are looking at here illustrates the emissions of aerosol particles from the source, a volcano, for example, and all from nuclear detonations, rise up to the higher layer and being physically and chemically processed in the atmospheres before they are removed from the air. So detailed understanding of the aerosol microphysics is needed. And currently, there are no data to improve the knowledge of the aerosol microphysical processes that are derived from nuclear detonations, period. Thanks. That's what I have. Now I hand it over to my co-chair to describe the impact studies.
Thanks very much, MD. So I'll start with physical Earth system impacts. And this chapter, for the most part, speaks to global scale impacts that pertains to the larger weapon deployment scenarios that would be capable of injecting large amounts of soot into the stratosphere and thereby reducing incoming solar radiation, thereby altering the radiative balance of the atmosphere, depleting stratospheric ozone, lowering surface temperature, and then changes and reductions in the global hydrological cycle and related changes in ocean state circulation and changes in the cryosphere. And sort of a flow chart is listed there with respect to what those impacts may be. Throughout the course of the chapter, it's identified areas of uncertainties or much more work needs to be done, and coming out of wildfire research in the previous chapters and a better understanding of how clouds and smoke interact under extreme conditions. As MD said, a better understanding from data of the ratio of black carbon to organic carbon, because it's the black carbon that causes this self-lofting that could penetrate from the troposphere into the stratosphere. And a number of previous studies just presumed pure black carbon. So that's an area of future research. As well as then, and kind of a theme for the rest of the impacts, is the systematic ensemble modeling studies of high resolution, looking at cloud aerosol simulations, and then coordinated simulations of the ocean response, the coupling between the cryosphere, and the hydrosphere, looking at, as previously mentioned, multi-phase atmosphere chemistry and probing that parameter and uncertainty space. The next, then, we follow from the physical impacts of the Earth system then to ecosystem impacts, looking at alterations in the physical Earth system where there may be disruptions to terrestrial and marine ecosystems and net primary production. And the plot on the right sort of illustrates what may happen as a reduction of incoming shortwave radiation. We would have a slowdown on a hydrological cycle and a decrease in precipitation, but at the same time, a decrease in evapotranspiration. And so you have this potential regional dependency of precipitation versus evaporation. And in one region, one may win out, in another region, the other. So you could have positive impacts on the net soil water balance or negative, and those then impact net primary production. And then with respect to both either terrestrial or aquatic net primary production, we don't have a good understanding of, after the decrease in incoming shortwave radiation, how does that partition to photosynthetically active radiation? Another big uncertainty. Another one is, our collection of models for the Earth system, for the most part, are dealing with secular trends. And we don't have a good understanding in our coupled models of the robustness of the coupled system, be it the physical system, be it ecosystems and socioeconomic systems, it's coming next, to abrupt changes and rapid cooling. So future research needs to develop models and look at the sensitivity to abrupt changes and shocks to ecosystems. And even apart from a global deployment scenario, there are regional impacts. If it's just a regional or a conflict between a handful of nations, and that's where the what, when, and where of the deployment comes in, because there can be a lot of regionality where the potential impacts are. And then lastly, social and economic impacts. This chapter really speaks to, as shown in the figure here, the interconnectedness of the Earth we live on. And we need to approach and attack this problem as a system of systems and look at the extent to which this system of systems is resilient to shocks. Will those shocks be dampened? May they amplify because we have a nonlinear system? And again, this aspect of regionality. So this chapter speaks to the impacts of the physical environment and ecosystems, to these sudden environmental shocks and how they may cascade across this interconnected system, be it agriculture, economies, health systems, transportations, systems. And in short, what we're talking about is looking at multiple stressors across multiple sectors. And just recent examples of such would be what we experienced during COVID, what we've seen in the Russia-Ukraine conflict and the impact on wheat prices. And again, as I mentioned earlier, the impacts to the Straits of Hormuz. So the overarching finding and recommendations for this study. Top line, there is insufficient coordinating modeling effort. We have a number of very strong parallel activities, but we clearly saw the need for much more coordinated modeling effort at the national scale to address these issues of teleconnected impacts and risks, and what that means for multi-sectoral dynamics that could ripple through the system. As I said before, be it a global exchange or regional exchange, the geographic context is really important with respect to key underlying conditions and vulnerability. So again, the what, the where, and the when is important. And then ultimately, we're dealing with human beings. And so what does this, the impact on decision making, and how will humankind respond to these attendant risks? And so the recommendations at a very high level for the study is the need to coordinate and the development of a support for a suite of model intercomparison projects from this perspective of a system of systems. We have coupled model intercomparison projects. We have agriculture model intercomparison projects. We have the integrated assessment modeling community. We have multi-sectoral impact, et cetera. And so we need to have a much more coordinated attack on this problem, which really requires a whole of government approach, such that these MIPS could identify what are those crucial characteristics, probe that parameter space, probe that uncertainty space so that we can reduce that uncertainties going forward, as outlined in that figure. So the key takeaways for this study, in the past, a lot of previous studies have focused on extreme case studies, and so there's a need, beginning with those employment scenarios, for a better understanding of the realm of possible outcomes. That then feeds into a cascading series of interactions, feedbacks, and uncertainties. And it's only the higher employment scenarios, plural scenarios, that are likely to inject significant quantities of particles into the stratosphere with global impacts. And so for the smaller scenarios, context is really important, the what, the where, the when. And again, even though a regional scenario could still have global implications because of the interconnected system of systems we live in today. And as we said at the outset, a lot has changed over the past 40 years. Dramatic decreases in the nuclear stockpiles, advances in Earth system science and Earth system modeling, and this development, as I mentioned, of a more globally interconnected world. And so really thank the sponsors, because the time was right to do this study. And on the last slide, I want to acknowledge the experts in the field that briefed the committee and the time spent from the number of reviewers that did review this. And with that, we'll then open it up to your questions. Thanks very much for your attention.
Thank you, Tony and MD, for that overview of the report. And we're going to turn to the Q&A session at this time. And we are welcoming several other members of the committee. As Tony mentioned, it's a very interdisciplinary committee. So the questions, either Tony can direct them, or maybe this committee, you can speak up or use the hand feature in Zoom if you like. And again, to remind the audience to use the box below your video player to submit any questions. And committee members, I'd ask that the first time you answer a question, just go ahead and quickly introduce yourself. Okay, so the first question we have is, why did the study committee use the 50% value of the available stockpile in their scenarios?
Let me turn to Mike Elliott. Mike, please.
Sure. The 50% value was used in part because all weapons aren't available day to day. The physical state of the weapons range from those weapons that are what we would call alert ICBMs, some portion of the SLBMs, to weapons that are in deep storage that wouldn't be available for even years for that. We examined the values that were used by other studies, and it was fairly consistent that about 50% of the values of the weapons were used in each one of those studies. The other factor is the target bases are today very different than they would have been in 1985. That affects the number of weapons required. I mean, the weapons are more precise today, which reduces the number of weapons that are needed for this. It was our judgment that any military leader is going to try to preserve some reserve for uncertainties, and therefore we settled on the 50% value, fully acknowledging that in other scenarios it could be maybe up to 50% greater than this. But bearing in mind, these scenarios were only a framework for the scientists to understand the implications of each different scenario and what factors they were going to have available to them.
Thanks, Mike. Does anyone else want to add anything? Okay, so next question. The phrase nuclear winter was for 1D studies with no surface heat capacity. 3D studies led to terms like nuclear autumn and nuclear drought. Is the term nuclear winter still really appropriate when there is not a global freeze?
Let me try a stab. I mean, we did not directly address whether or not, it was not in our statement of task. This is an area where we need to have further fidelity on the deployment scenarios. I would say that, you know, when we looked at the amount of carbon that could be injected into the stratosphere is anywhere from 5 to 12 teragrams for the largest scenarios. And order 1 for the medium scenario. So those are considerably reduced from the very, very high end scenarios from 35 years ago.
Okay, and a related question, is nuclear winter still possible with these scenarios? Oh, sorry, Jim, go ahead. Jim wanted to add.
With respect to Alan's question too, I would just want to add to what Tony said that for the moderate to larger scenarios that we looked at in the literature, it was very clear that sea ice expanded 1 to 3 or 4 years after the detonations, and also there was more snow on northern continents. We did not explore a scenario, hasn't been one published, where there was a permanent shift in climate. Most of the scenarios were covered after a period of 1 decade. But so I think our report focused on the environmental effects, and we didn't address the question of whether nuclear winter is appropriate, but we did see an expansion of ice and snow, and that is a robust finding across multiple modeling communities.
Thank you, Jim.
Okay, and then the related question, yeah, okay, the nuclear winter is still possible with these scenarios. You just answered that correctly. Okay. So
Yes.
next question. For what fraction of weather situations would hot fires aloft significant amounts of black smoke up to mid and upper troposphere? For example, there was little lofting of smoke from Kuwait oil fires and unlikely in stable subtropics.
Think either Jim or Aishi or MD.
Aishi, would you like to go?
Sure. So for the amount of smoke or black carbon to be lofted high into the stratosphere, it really depends on many conditions, especially weather and also the scale of the fire. We reviewed many studies. If it's from the nuclear detonation, it's different from other fires. So that the scale and also the aerodynamics will be different. The exact amount will really depend on many factors. And there's also a lot of uncertainties pointed out in the report. There's no definite answer to that question. The small portion, but the exact number will change depend on many factors.
Others?
I would just add to that you know, there's the commenter makes the point, the shear is really important in the atmosphere. It is likely that the fuels inside cities are going to be very dry inside buildings, the paper and the wood products. So that will lead to a more intense fire compared to what might happen with different fuel moisture levels in a natural ecosystem.
Okay. The next question. How does your study reconcile the divergent modeling approaches and findings between researchers who find catastrophic nuclear winter outcomes and their critics, some of whom work within the U.S. nuclear weapons complex?
So we took into account the whole body of literature and the state of the science as it was 35 years ago and as it is today. And that then feeds into areas where we need research. So I said, as I alluded to before, there have been a range of individual studies on parallel tracks, and some of them have had varying assumptions going into their initial conditions, as MD said. And that's why we recommend a much more organized series of model intercomparison projects to address some of these uncertainties.
Anyone else want to add? Here's a related question. In addition to stating uncertainties in future research needs, does your report provide conclusions on what is already established from recent scientific studies on the effects of nuclear war on climate, food production, etc.?
Nancy, let me start. While we looked at several studies, none, and Tony pointed that out, none really have looked at it from a systems approach, and particularly the interconnectedness of systems and the system of systems. So for example, if we only look at the socioeconomic impact, it's a system of ecosystem services where we particularly are worried about the global supply chain and food production and issues like nutrition and malnutrition specifically, connected to the whole area of human health systems, both the individual person as well as the infrastructure and the resilience. And then thirdly, connected to that, and so it's ecosystem services, human health impacts, but also societal impacts. And the resilience of a given community will determine ultimately the cumulative impact. So the interconnectedness of systems is not well addressed across the studies that we've reviewed.
Thank you, Maureen.
Others want to add to that? Okay, the next question. Have the uncertainties been identified and prioritized? For example, emissions, lofting, i.e. the source term, versus the impacts modeling? Does that make sense? Have the uncertainties been identified and prioritized versus the impacts? Also, can we draw on ongoing solar engineering, GeoMIP type scenarios? How about natural analogs?
Okay, there's thanks for the questions. And so the first part of the question with respect to uncertainties identified and prioritized. I said for the report as a whole, the highest level recommendation is the organized model and the comparison project. And then each individual chapter, be it fires, the physical impacts, ecosystem impacts, chemistry, they identify the uncertainties or the priorities, the findings and recommendations for that community. And again, that's what feeds into that flow chart of the cascading uncertainties. But we did not choose to prioritize one chapter's finding and recommendation over another because of that chain. We thought they were all important and significant, short of the overarching recommendation. With respect to drawing on ongoing geoengineering, GeoMIP type scenarios and natural analogs, yes, we had addressed, for example, volcanoes and GeoMIP, solar incoming solar radiation management scenarios. We addressed them, but for the most part, we learned from them, but they're not directly relevant to the problem at hand. And so hence the ultimate recommendation, because we're talking about, again, the injection of soot into the troposphere and the stratosphere, the interaction, what is that ratio between BC and organic carbon, the issue of drops in temperature and incoming shortwave radiation. So yes, we learned from them, but we think there is a need for a much more concerted effort, separate and distinct from those.
Thanks. Jim, did you want to add? I saw your hand go up.
Well, I would just add to Dubé's question, within the fire component that's nested, as Tony described, that there's, there are high uncertainties and we need better observations of the chemical composition of aerosols and trace gas material from urban and wildland urban fires. So that's a critical observational gap, along with emissions loading estimates across cities. Then couple that with on the modeling side, both the fire dynamics within a city and then also the coupling that with the plume, or I would say those four together are critical, but they have to be viewed in that nested hierarchy and cascade that Tony was describing.
Thanks, Jim. Okay, next question. Given the potential significance of fallout, why was it excluded from this study? Will it be considered in future studies?
No, We can only speak to the statement of task we received from Congress to NNSA, and that was the guidance we received from the sponsors.
Thanks. And a related question, is there currently exploration of the impact of nuclear fallout aerosols interacting with existing aerosol outputs from chemical plants and commercial production?
I'll turn to MD, but that's not necessarily consistent with the statement of task, MD.
Oh, you're muted, MD.
So I would like to say this is an interesting question. It's hypothetical and it's also out of the scope from the studies. But it's likely the produced material from the nuclear detonation would interact with whatever material that is existing in the air, and it could modify the property of those aerosols as well. But those are just based on the knowledge on aerosol science that we know about these days. We don't have the data from nuclear detonation to be more precise per se.
Thanks, MD. Maureen?
Yeah, I want to add that this, while it's out of the scope of our study, it's an excellent example of what geographical vulnerabilities exist in a community. So if there are already issues that contribute to air pollution, that makes the impact even worse.
Thanks, Maureen. Next question. Can you describe modeling studies that have been done and the range of forecast impacts? Does this study have anything to say about the credibility of those studies?
So those questions are right for a whole 1 hour scientific presentation. We do address those in the report, ranging from the nuclear winter mutual assured destruction scenarios between the US and the Soviet Union to a more limited exchange between India and Pakistan. And it would not be appropriate for us to ascribe credibility to these studies because, as I said, over the past 35 to 40 years, a lot has changed with respect to nuclear stockpiles, yields, strategy, etc. So what was the state of knowledge 35 years ago is not representative of the state of knowledge today.
Okay. Next question, how can private initiatives help contribute to the clearly large volume of research that is still needed? What recommendations would you have to optimize private grants for such studies?
That's a great question. And I would encourage NGOs and philanthropic organizations to look at the recommendations in the study. I mean, there are, as Jim said, there is need for better data, for example, on fuel loading. In the United States, we have a pretty good understanding of the built environment. We have information from satellites for the globe, but not to the same level of fidelity we have in the United States. So there is a need for data processing. There is modeling activities that the private sector and philanthropic organizations could contribute to. Maureen?
I would encourage that, and particularly in the area of AI, machine learning, and predictive modeling. That's an excellent opportunity for the private sector to participate, particularly also when we work with communities in a collaborative fashion, for example, on implementation studies. So I see plenty of room for us to do this as one team because the multi-streams of data require that kind of complex data integration.
Thanks. And a kind of related question, if NNSA is unable to fund climate studies, what agency would be best to fund the studies recommended in the report? Jim?
So thanks for that question, but let me be very clear. We're not talking about funding climate studies. We're talking about looking at the Earth as a system of systems, and it's not a euphemism, all right? This is not a climate study. And so, as I said before, we do require to make progress on this problem of whole of government, and it would involve Department of Energy, NOAA, NSF, NASA, EPA, just to name a few of the important agencies. Maureen?
So building on your answer and the excellent question, this indeed is not a climate study. It is about what the insults are and what the contributing factors are, what the risk factors are, in addition to a nuclear event. And so there are risk factors that are related to the environment, environmental pollution, for example. There are risk factors that relate to people, cultural preferences of people, people's health. There are risk factors that relate to severe weather conditions. So taken together, that's why our emphasis in the report is about a systems of systems, but this is not a climate study.
Jim?
I would just add to that, that we really have to think about this cascade. The US does have really critical Earth system modeling capability, including the E3SM model developed by Department of Energy, NSF's Community Earth System Model project. And these are critical tools used widely for many different applications. And I guess I just want to highlight the importance of keeping those sets of modeling systems going to support the U.S. national security needs.
Okay, thanks, Jim. The next question, is governance one of the model intercomparison areas addressed? That is, does the study look at the impact on decisions of government officials and related actions of citizens?
Yeah, let me
No,
take that one first. A report from the National Academy of Science, Engineering, and Medicine really addressed the domains of community resilience. And governance is a critical domain of that. So depending on how the governance works, whether it's a central governance system, a decentralized governance system, a governance system that where cities have leadership and part of the state or part of the region or part of a county health department, governance plays a key role in decision-making from where the data are coming from, what the priorities are, but particularly how communities are included in those studies.
And I would say that governance is not addressed in the study to the same extent that we talk about governance in the geoengineering world. However, building on what Maureen said, we do recommend a further study of the human response to what's discussed here, and recommend stress testing, much like stress testing of banks, for regions and governments where that may be vulnerable, and for regional scale deployments, where some regions, as a result of governance and human responses, may be more vulnerable to regional deployment than other regions.
Indeed, Tony, you're right, because there are regions in our country, for example, that are prone to natural disasters. There are regions that are prone to natural disasters and technological disasters. Those regions are good examples of vulnerable regions where we can prioritize not only our research, but particularly prioritize resources to address those vulnerabilities, particularly in people, as well as in ecosystem services. We didn't talk a lot about the importance of agriculture and the supply chain, but that's critical for us to address not only the human impact, the human health impact, but also the ecosystem impact.
Anyone else?
Thank you, Maureen.
Thanks. Okay, next question is about fire. U.S. homes are particularly vulnerable to cascading urban fire spread when the inter-home spacing is less than 25 to 35 feet. Have risk maps been created for the areas that would be most susceptible? If not, should this be recommended?
So we go ahead, Ashi. Yes.
Yes, I can try to answer this question. I think for us in the US, because of a lot of residential buildings are made of lightweight construction, very combustible. We've seen many wildfires or forest fires in the past many years. And because of that, we have fire risk mappings supported by national agencies or federal agencies and also state agencies. So we do have some fire risk mapping in place. However, not much work for urban areas. These areas are for urban, for wildland or wildland-urban interface, not urban. Definitely, there's a need to have this in place as well.
Thanks, thanks.
Thank you.
All right. So I'm gonna probably need a little help parsing this question. Would not major exchanges be likely to be counterforce instead of counter-urban centers? So is fuel load not quite low in counterforce exchanges?
Mike?
I got it. Without talking about the likelihood of whether something would be counterforce, and for those who are not familiar, meaning would the two sides go after their military forces exclusively, a combination of military forces, leadership, in military industrial complex, if you will. As a general rule, I would say military forces are generally speaking outside of urban areas. Some, for an example, ICBM fields, well outside urban areas. And as a result of that, we know that they would have substantially lower fuel loading for those areas. Something like a military base, behavior is they're built out in the middle of nowhere initially, and then the population centers grow to those military bases. So there's some that are well outside urban areas. There would be others that are near urban areas. And then in some cases, leadership and industrial would be in the urban areas. So yes, as long as there's an attempt to go after forces, that reduces fuel loading as a general statement.
Thanks, Mike. Anybody else would like to add?
Mm.
Okay. Next question, how did the study address possible tipping points that may trigger environmental and societal breakdowns?
Let me turn to Jim.
We have Osvaldo and
Yeah, maybe Osvaldo or Jen.
sorry.
So
Jason.
Osvaldo.
tipping point is a very interesting concept, especially because it has major implications for management, because there is a state in which the system changes and is irreversible. But in our study, we have not identified any tipping points. Tipping points occur mostly in smaller scale systems. At the scale of this study, we did not identify tipping points. There were not major studies showing the existence of those irreversible behaviors. Thank you.
Thank you, Osvaldo. Jason.
Yeah, and I'd just like to add in that we did acknowledge that tipping points potentially exist, but because of the great degree of uncertainty in particularly environmental and social systems, it's extremely hard to identify these tipping points right now. But I think to the recent point is that because globalization has increased so much over the past several decades, even the localized tipping points that Osvaldo just mentioned, may be at a local scale. The cascading effects on the global economic and social systems are real and something that we acknowledged in the report as important avenues for further investigation.
All right, thanks, Osvaldo and Jason. See, the next question is the scope NUR study concluded disruption of intercoupled international economic system in major exchange needed to be considered as a major deterrent, perhaps even more important than climatic effects to non-combatant nations. Thoughts on that?
No. Mike?
I'm sorry, could you restate that?
Sure, yeah, it's in the chat, Mike, in there. The scope NUR study concluded disruption of intercoupled international economic systems in major exchanges needed to be considered as a major deterrent, perhaps even more important than climatic effects to non-combatant nations. Do you have thoughts on that?
I'm still trying to understand the question, the interconnection.
I think it's So economics might be the most important impact.
Again,
Well,
I
sure.
mean,
Go ahead.
I mean, Mike, please. No, I'm just gonna say, deterrence, non-deterrence was really not part of the study. We do call for, more research coming out of the military intelligence community regarding the potential range of scenarios of which this would feed into. But again, deterrence, non-deterrence, that was not part of our charge.
Yeah, and to follow up with that, now that I've digested it, I would say that it's not necessarily more relevant in it or greater deterrent. It's the interconnectedness of the effects is what the entire study was about, is how these things relate is a group to the different parts of it. But economics certainly is going to have some impact.
Thank
I
you.
would just add to that it's clear, in the latter chapters of our report that the climate perturbations that were our focus would considerably lead to disruption in economic systems. So I think that it is difficult to understate the importance of the economic disruptions.
Thanks, Jim. And I'm going to make this one our last question because we are at time. How do we create synergy between private, public, and federal, including military research?
As a human health.
Wonderful question. Let me just say, that's a wonderful question. It's beyond the scope of this report. It's really a question oriented towards the academies, and there already is a roundtable in the academies for government, industry, and philanthropic partnerships. And so more coming out of the academies along those lines. And Maureen, did you have anything to add?
Yeah, I just wanted to say this is, as a human health researcher and human health scientist, this is absolutely so critical. And typically and traditionally, we have waited for the federal government to issue a request for proposals. I think increasingly foundations are stepping up and issuing requests for proposals where it is more of a collaborative effort rather than only a governmental driven effort. But our roundtable will help with focusing that effort and energizing that effort. But I would be a great supporter of this to happen. Thank you.
Thank you, Maureen.
Thanks, Maureen. All right, so we couldn't get through all the questions. We had a pretty large online audience. We thank you for submitting those great questions, and I want to extend the thanks to the committee that are here, and also the committee members not here today, for the time you spent with the National Academies to produce this important study. I want to remind those in our audience that we will have the recording of this session in the next few days, and that the report is free and available to download at the nap.edu. And that's it. Stay cool, everyone, and we thank you for joining our webinar.